And here we go again, 6.5. Been alive with 6.5. Solving square roots and other radical equations. So if you want to pause and read this whole thing up here, you may do so. Good, I'm glad you read that. One thing to be noting is that you have to always isolate the radical. So isolate the root or isolate the fraction exponent. The other thing that I'm going to show you here, remember if I had something like this, x squared is equal to 4, when you're solving that, that'd be x is equal to a positive and negative 2. Now the reason being is because when you take the square root of 4, that's the same thing as doing 4 to the 1/2 exponent. There's two numbers here. So when we're solving, if we have an even root or else an even denominator when we're solving, we have to represent two answers. And we'll get into that in a little bit. So my first question, you have to get the root by itself. So before you do anything, you have to get rid of this 3. So when I'm thinking in my head, that's a positive 3. So opposite of a positive would be a negative. I'm going to zoom in here a little bit, give myself a little bit more room. So I'm going to have to subtract 3 from both sides. So once I subtract 3, so my square root of 2x minus 3, and that would give me 5. Now I have to think what's the opposite of squaring something, or square rooting. That would be squaring. So when I'm doing this, I only have one answer, because this would be like 2 over 1. That's an odd denominator. So I have 2x minus 3 is equal to 25. And now I can keep on solving, so I have 2x. I have to add my 3 over, so that'd be 28. And divide by 2, x would be equal to 14 here. Again, I only have one answer. Right now you should pause the video and try to do the b by yourself. So this is the same thing as a root, because the fact that we have a fraction exponent. Remember, fraction exponents are roots. First thing I want to do is isolate this right here. So isolate the root, essentially. So I have to get rid of this 3. This is 3 times. Opposite of multiplying would be dividing. So I divide. I have x plus 1 to the 2/3 power is equal to 4. Now there's two things that you could do here. You could rewrite this as a root, and you still should get the same answer. However, what I notice here, and if you read the above to solve the equations, so right above problem 2 it says to solve the equations, when you have m to the nth, you can take it to the reciprocal power. So I'm going to take this to the reciprocal power. So this would be 3/2 power on this side. Whatever you do to one side, you have to do to the other side. The reason why we do that is because we have this power to a power right here. And when you have your power to a power, you multiply. And 2/3 times 3/2 times the reciprocal will give you just what's in the parentheses, so x plus 1. The thing you have to be careful about on the other side, you can put that into your calculator, but essentially what you're doing is doing 4, the square root, because this is bottom, it's a 2, so this would be the square root of 4 raised to the 3rd power. Or else put in your calculator, either way you should get 8. But when you are writing your answer, whenever you have this even denominator, when you're solving and you have an even denominator, so right here, taking 4 to 3/2, you have to represent the positive negative. Because remember, there's two numbers that could make this true. Two numbers that would make it a true statement. Now, you can either write up two equations like so. That's not right. So x plus 1 is equal to 8. Or x plus 1 is equal to negative 8, and you solve for both of them. So both of them, you subtract the 1 over, so it'd be x is equal to 7, 8 minus 1, or equal to negative 9, because subtracting the 1. Now for the second one, you're going to try to do this by yourself. And one thing that might help you, if you rewrite this, because of the fact that you have exponent and a root, to rewrite this as a fraction exponent. But the first thing that you should be doing is getting rid of this, because you want to do the opposite of PEMDAS, so you want to get rid of that, and then this. So if I rewrite this equation, so it would be 3, and then the x plus 1 raised to the 3/5. So rewriting that root. Again, the first thing you should do is subtract the 1, so you have 24. And then I believe you should try to do this by yourself, and I'll go over the answer. But one thing I do notice right here is the reciprocal is 5/3, so it would be an odd denominator, so there should only be one answer here. And here again, I want you to try to do C by yourself. C by yourself. I'll be going over those questions tomorrow. Very important. It says very important. One thing is that you check all solutions, because right now we're going to be dealing with extraneous solutions, meaning once I solve it, it's going to be true, but it does not always work. And the reason why it does not always work is because we have an x on both sides of the equation. So I'm going to do A, and then you're going to try to do B by yourself. And again, we have to check for extraneous solutions. So the first thing I'm going to do is add over the 5. Same thing that we just did. So I have my square root of x plus 7 is equal to x minus 5. And just like we did before, the opposite of square root would be squaring something. This is a big mistake that people a lot of times do. They just try to bring the square root to both of those. However, that's not what this is saying. This is saying x minus 5 times x minus 5. So you have to FOIL. So you should FOIL. And if you notice, that should say x plus 5. And when I FOIL this, this is what you should get with combining your like terms. If you're not sure how I got this right here, you need to come in for help. And one thing, when you're solving, you have to move everything over to one side. So I'm going to subtract my x. I'm going to subtract my 7. So I have 0 is equal to x squared plus 9x plus 18. And now you have to factor. So two numbers that multiply get positive 18, add to get 9. Those two numbers would be x plus 6 and x plus 3. Again, they multiply to get 18. They multiply to get your C. Add together to get your B. And if I solve this, my two answers would be x is equal to negative 6 and negative 3. That's great. However, you have to check. So I'm going to go squiggle, squiggle, squiggle. You have to check your work, always. When you're checking your work, it would be good to make sure you stay nice and organized. So I'm first going to check x is equal to negative 6. You go to your original problem. So I take the square root of negative 6 plus 7, subtract 5 is equal to negative 6. I have to see if that's true. Negative 6 plus 7 is going to give me a positive 1. And then I would have 1 minus 5 is equal to negative 7, or negative 6. This gives me a negative 4 is equal to negative 6. That's false. So that answer will not work. Now I'm going to check to see if x is equal to negative 3. If I check negative 3, I have the square root. Negative 3 plus 7 minus 5 is equal to negative 3. Negative 3 plus 7 is 4. Square root of 4 is 2. 2 minus 5 is equal to negative 3. That is true. So since that is true, my only answer is x is equal to negative 3. Now one question you might be asking yourself, does that always happen where one is true and one is false? It happens a lot, but does not happen always. Sometimes both answers will work. So right now I want you to try B by yourself. Try to do B by yourself. And the next one, when we have radicals on both sides, it's a lot like the previous problem. So you have to first get the square root all by itself. So initially this square root by itself. So I'm going to add over my square root to x. So I'm going to have the square root of 2x plus 1 is equal to 1 plus square root to x. Same thing as before. You want to get rid of the square root, so you have to square it. Again, you're not just going to distribute that square root because you're smarter than that. This becomes 2x plus 1. You're going to have to FOIL this out. So you could write just 1 plus square root x, and you have to FOIL. And when you FOILed, you should have gotten 1 plus 2 square root x plus x. So if you're wondering where the x came from, square root x times square root x is the square root of x squared, which simplifies just to be x. So now, same thing, you want to move everything over besides your square root. So just like you did up here, you moved everything over beside the square root. Same thing here. So I'm going to subtract my 1. I'm going to subtract an x. So you're going to have x is equal to 2 square root x. You want to square this, so both sides, so this becomes x squared. Now this is where you have to be careful. The square root has to go to both the 2 and the square root x, leaving you with 2 squared is 4, square root x squared is x. Now when I'm solving that, I'm going to move everything over. X squared minus 4x is equal to 0, and you solve. Now you either are going to have to be solving using the not quadratic formula by factoring, or looking at this, I can take out an x. So I'm leaving with x minus 4, set both of those equal to 0, and I get that x is equal to 0 or positive 4. You have to make sure to check your work. If you do not check your work, you might say, oh, both of those are answers, but they're not both answers. So I'm going to go squiggle, 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 and check. So x equals 0. That's the first one I'm checking. So the square root of 2 times 0 plus 1, again, looking at my very first, what was given to you, is equal to 1. So the 2 times 0 is 0, plus 1 is the square root of 1, which is 1. The square root of 0 is 0, so 1 equals 1. That one's true. And the second one, the square root of 2 times 4 plus 1 minus the square root of 4 equals 1. 2 times 4 is 8, plus 1 is 9. The square root of 9 is 3, minus the square root of 4 is 2 is equal to 1. That one's also true. So for this one, you actually have both answers. Both of these are correct. So x equals 0 and x equals 4. I want you to try it. Beep, 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 beep. And then I'll be going over those questions tomorrow in class. Thank you, and have a great time of your life right now.